and welcome back to my series on contemporary mathematics from OpenStax. In this video, I'm going to cover section 8.3 on mean, median, and mode. Another term that we often use when discussing this information is something called the measure of central tendency. So measure of central tendency is often used when talking about center. And so we can summarize, in many cases, this idea of mean, median, and mode by calling it measure of central tendency. So we're looking for things in the middle, in the central portion of our data set. All right. So what are we going to cover in this video? We're going to talk about the following learning objectives: the ability to calculate the mode, calculate the median, and calculate the mean. We're going to contrast measures of central tendency to identify which is the most representative of what's, quote, average, and then solve applications involving median, or mean, median, and mode. So really the main story here is we're trying to figure out what does an average element or item in our data set look like. So what do we mean by average? So is the height of an average person the height that more people share with than others? What about average like foot size and things like that? And so when we're talking about median, and mode, we're looking for kind of this idea of what's average. And as the book does talk about, that's an important thing, that mean, median, and mode are clumped underneath this idea of something called central tendency or centrality. And that is just a word that describes the middle of a set of data. And sometimes it is an actual data point within it. In other words, it's a number that comes from the data set. And then sometimes it's not. Sometimes the point of central tendency is not in the data set. It's a number that doesn't appear in any of the numbers that we've been given, but it is the best representation of what is, quote, average. Life expectancy is kind of a good example of that. We would say that the average life expectancy of the male in the United States is probably around 77, 78 with a decimal in there, so maybe something like 77.8. But, how many people live exactly to 77.8 years on average? So that's kind of how that is. So we'll start by looking at our first measure of central tendency, which is the mode. And so the mode, I like to think it rhymes with mode, sort of most. So mode, most, or they're both at least start with M. So which data point occurs most often in a set of data? And so here we have this stem and leaf plot for the sale price of a particular collectible trading card. And so we've got $5, $8, $9, we've got several $10, $4, $14, $15. So which occurs most often? So here we see that we've got 15 represented 4 times, we've got 20 represented 4 times. So that looks like we have two numbers that are represented twice the most. So we've got 15 4 times and we've got 20 4 times. So if we show the answer, we should have two modes. Both 15 and 24 occur 4 times more than any other value. So they are in fact our modes. So we can have more than one mode in a data set. In this case, we do 15 and 20, and we call that bimodal. Bi coming from the Latin prefix for two, and two modes. Essentially, we can be trimodal. We could have 3 modes. If we have any more than that, we would just say that it is multimodal. All right. So again, I highly advise you to pause the video and try the your turn to see what would be the mode of this particular example. So mode's pretty straightforward and easy. I wanted to take a moment and bring up Excel to just kind of show you. So if we had, I'm just going to make up a list of numbers here. And so in Excel, if we do equals, which what calls a function, and do mode, we're going to have this kind of autofill, and we see we have two mode functions. This third one is actually, it's got an exclamation mark on mine, which means it's just there for compatibility purposes. So we really don't want to use that one. But we've got mode mult and mode single. So mode mult or multi-mode means that it's going to return more than one mode if it exists. So we can double click that and highlight, make sure that we close parentheses, and we see that here we have a mode of 5. Now if we added another 6, you'll see that it pops in that extra 6 because now it's multimodal. So if we had 4 7s, I bet it's because, yeah, my equation stopped at 15. So I can actually, let's just bump this to like 100, so it'll get this whole column almost. And so here you can see now 7 appears 4 times, 6 appears 4 times, and 5 appears 4 times. So we would have those two modes. But if we change this to like 8, then that drops the 7 off. And if we change this to another 7, then 7 becomes, and so that's using mode mult. If we use the single, then it's just going to return 5. It should return 7 as well, but it's just going to return the first one that it picks up. So you got to be careful using single. I would advise you using that mult so that it picks up all of your modes if you have them. And so that's how you can use mode in Excel. So here's an interesting example. So this is from a frequency distribution. So what this is saying is the number of siblings 0 occurred 5 times. Number of siblings 1 occurred 13 times. 2 occurred 6 times, so forth and so on. So what is the mode of this? Well, the frequency tells us how many times there were. So for mode, all we need to do is say, well, which had the highest frequency? Well, there was 13 people who had 1 sibling. That's the mode. And so if we look at the solution, you will see the mode is 1 because 13 people had 1 sibling. So looking at a frequency distribution is really quick. You're just looking for who had the highest number. Now, if they matched, of course, it would be multimodal or trimodal, so forth and so on. So this one's really quick and easy. For your turn, if you want to just pause it real fast and read it to see what it is, but just to give you the answer, just give you a moment to pause. All right. So if you picked it out real quick, 13 is the most. So 2 would be the mode of the number of people in the residence. So now median is a little more interesting. Median is talking about where you lie inside of a distribution as far as the quote-unquote middle, the true middle. All right, and that's the median. So if we look at a really simple example here, we've got 5 values. Let me highlight it. We've got these 5 values. They are listed in ascending order, meaning from least to greatest. That's super important. When you're finding the median, it has to be from least to greatest. So here we have that. And if you notice, 13 is smack dab in the middle. So in this case, 13 is our median. It lies at exactly the 50% point in our data. So kind of looking at this chart, you can see that number of values below 11 are 0, number of values above is 80%, and so forth and so on. So only 13 has no violations, that it is the median according to the definition. All right, that it is that no more than 50% of the data is less than or greater than it. So that's kind of a formal way of doing it. An even more formal mathematical way of doing it is, suppose you have a data set with n values, so like 10 numbers, 11 numbers, then you sort them smallest to largest. We call that ascending order. If n is odd, then we take and add 1 and divide by it. And then if n is even, then we divide by it and add 1. And so those values are named A and B. Then the median is defined to the median is defined to be A plus B for evens. So let's look at an example here. So we've got 33 sale prices. So what we can do for this is, because it's an odd number, 33, we can bump it up. We can do 33 plus 1, so 33 plus 1, and divide that by 2. So that's going to give you 34 over 2, which is 17. So the element in the 17th position it would be the median in this case. So starting here, we have 5, 8, 9. So that's 0. That would be first, second, third, and then we would keep counting until we got to 17. So if we counted up until we got to 17, that should be this 0, which corresponds to a value of 20. And so if we come down here, you see it's the same thing. And so we count up until we get to, so the 17th number is 20, and that means the median is 20. So I'm going to walk through this your turn with you, just so that you have another good example, because these don't take too long. So again, our data values are, once again, even or odd. So we would do 17 plus 1. So 17 plus 1, and divide that by 2. So that's going to be 18 divided by 2. So that's going to give us 9. So we're looking for the value in the 9th place. So this is 121. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And so 136 should be our median value for this data set, since it is in ascending order with the stem and leaf plot as it is. So that's the your turn there. So what about looking at the data in this regard? So I'm going to put this into an Excel sheet, and so we can look at that, because we need to sort this from ascending, and we need to then look at the middle. And doing that by hand can take a lot of kind of tedious things, and if you mess up, if you get one number out of place, you're potentially wrong. So what I'm going to do is I'm going to take and put this into Excel, and then switch over to Excel and kind of show you how that works in a spreadsheet software. You can use Google spreadsheets, but if you are a student at Mitchell Community College, then you do have free access to Microsoft Excel online, and you can download it as well. All right, so I put the data into an Excel spreadsheet into a column like this. So you can see that this column I put in, and then I just added it to the bottom of that column. So we have all 30 of our values. You can always check. So Excel has a count function, which just counts how many things are in. I'm just going to click this A so that it highlights the entire column, and it has 30, and we should have 30 values over there. So we have 30 items to count. One thing we can do in Excel that's really nice is we can actually sort it. So once I highlight the column under the Data tab, so you should start in Home, but over here in the Data tab, you have Sort and Filter. So if you go down to the A through Z, it'll sort from smallest to largest, and it will put them in from smallest to largest. Now in this case, we have an even number of things, right? So go back to that count that we had. We had 30, and so what we would do here is we would half it and add 1, and so that would be 15. So that would be at the 16, 17 mark. So these two are going to be halfway in between of our data points. And so we're trying to actually find the average of these two, because we don't have an odd number of things. We're going to have this amount on this side and this amount on this side. Then and you can see down here it's taking the average as 102.5. Again, when Excel says average, it means the mean, which we haven't talked about yet, but you probably know what that means. So we have 30 elements, so we're really looking at the average between these two. And so that would be 12.5, because it's going to be in the middle of these two. We could also, because Excel can do it as well, just ask for the median by doing equals median and pressing enter, and it has 101.5. So I guess it should be these two. that we're getting is the halfway. Oh yeah, sorry, it's the halfway and then plus 1, not plus 1 and then above. So it's between these two. And if we were to count, all right, let's say what we counted off, how many are on the left here, then we've got 14 on this side, and then 17 through 30, right? Yeah, so we have 14 elements below and above these two values. And so if we add it in, let's see, I think it inserts below. So if I just insert it here, then that would split this into an even 15 elements and 15 elements. And this is where the median would occur of 101.5. And so the median, again, is to split down the middle, essentially, and that would be the median of this even amount, which gives us the same thing as this, because it's the average of those two values there. So that's how we can calculate the median. If we were to do it by hand, which the book does, so if you click Show Solution, you'll see that it orders them in ascending order from least to greatest, and then we look for the middle two, which we found to be 101 and 102. So those are the two middle values, because that would be 30 divided by 2 is 15, so that would be the 15th and 16th spot, which it tells you here, the 15th and 16th spot, and then the average of those two is 101.5, which is the same thing as our Excel function of equals median as well. So you can try that with this one. So in this case, we want what is the median number of wins. So this we would only want to calculate the median on the wins. I'm going to leave that to you to do. You can do it either by hand, you can do it by Excel, but it's good to practice one way or another that you're going to calculate the median. Now, what about the median using a frequency table? That's a little different. So there's several ways you could think about doing it. And I will show you as many ways as I think is necessary. So let's first look at the kind of the quote-unquote hard way, and thinking that what we're talking about here is the number of siblings and the frequency. So this means that 5 people had 0 siblings, 13 people had 1 sibling, so forth and so on. So how many people do we have? So if we add all these numbers up, we get that there are 30 people when we add all of these. So there's a total of 30 people here. So again, it's an even number. So we're looking at between the 15th and 16th position. What number is there? So it's going to appear, so if we write out these first few, I'm going to do this longhand just to show you. So we've got 0 5 times, and then we've got 1 13 times, so that should be 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 elements. We're looking for what's going to be 15 to 16. So if this is 18, 17, 16, 15. So these two ones make up the 15th and 16th element. But they're the same, right? And so according to the rule of calculating the median, what we're supposed to do is add these and divide by 2. So that's going to be 1 plus 1 divided by 2, which is just 2 divided by 2 is just 1. So we end up getting that the median here falls in this bucket, and so it's 1. If it was on the cusp, if it was a 0 and a 1, then it would, like, if it was in here, then it would be like 0.5. But because it falls within the same frequency bin, that we get it to be the same. And so we can kind of come down here and look what they say. So there's 30 values. We're looking at the 15th and 16th one. So there's 5 zeros and 13 ones. So items 1 through 5 are 0, and 6 through 18 are all 1s. And so since the 15th and 16th are 1, the median is 1. So that's exactly what I just said. I just kind of wrote some more information out. Now, how can we do this in Excel? Right? Because I like Excel. It makes things a little visual for us. So I'm just going to bring up Excel and kind of show you. So I can highlight everything and press delete, and so it'll clear everything. And so I need to move this over just a little. There we go. So that I get those frequencies in there. And so we've got 0 5 times. We've got 1 13 times. And so I'm going to skip ahead and type all these in and kind of show you and come back once I have those typed. All right, so I've typed them all out with their frequencies. And so here you can kind of see we've got 5 zeros, we've got 13 ones, and so forth and so on. So if I wanted to calculate the median, I can just use the function median, and if I do A colon A, that highlights that entire first column. You can also do that just by clicking the A when it makes a down arrow, and we see that once again we get 1. So that's how you can do it in Excel. A better way is actually if you were trying to turn something in, like if you're doing this for a job, then you would want to say like median equals, just so they know like what is this random 1 doing here? Well, it's the median, just so you give yourself a label so you don't get confused later, or it's more clear if you have to share the spreadsheet. But that's how we would do it. We would just type them out with the number that the frequency is, and we can calculate the mean. We could do the mode that way too. So and then so if we wanted the mode, we can do mode. I would always default to mult just in case you have more than 1. I don't think this has, no. So the mode is also 1. And we'll do the median in just a minute. But that's how you can do median either by hand or using Excel with this type of problem when you have a frequency distribution. And then finally, we have the mean. And so the mean of a data set is the sum of all the data divided by n. So you add everything up, and then you divide it by the number of things there are. So in this case, we would just add 12, 15, 17, 18, 18, and 19, and then we would divide by 6, because there's 1, 2, 3, 4, 5, 6 elements. And so you can just kind of see that that's how we calculate the mean, which you've probably just called the average in the past, but average and mean, average has this, kind of different term. I mean, it's kind of like a colloquial term, meaning what's everybody kind of look like, as where the mean is the mathematical name for actually calculating the sum divided by the number of items. So let me just do that real quick in Excel. This one's not that long, so I'll just highlight everything, press delete. So if we just enter these data points, we can just do or I think it's better if you label it so the mean is equal to and then equals mean. Now, mean is not a function in Excel. It is, in fact, actually average. And so A colon A gets the average of everything in that A column. And again, it's 16.5. So that's how you can calculate the average for something in Excel. And then how do we do that with a frequency distribution? Well, it's by hand we can do it, or once again, we can just read out all of those. So if I undo my deletion that I did, this is once again the frequency distribution for the siblings. So if I do mean equals and do equals average, I know that's a little confusing, but that's just how Excel has defined mean is average, and press enter, then notice this time we actually get 1.56 repeated. So if we had more decimal places here, the 6 would go on forever. How on earth did we get this? So what we're looking for is how to add up all those numbers. So we have 5 copies of zeros, so we can say 0 times 5 plus 13 copies of 1, so 13 times 1, plus we have 6 copies of 2, so 6 times 2, plus, and then we have 3 copies of 3, so 3 times 3, and then we have 2 copies of 4, so we'll do 2 times 4, plus 1 copy of 5. And so if we add all that up, so we do 0 times 5 is 0, and then 13 plus 12 plus 9 plus 8 plus 5, we end up getting 47, if I did that right. And then we're going to divide that by the total number of things that there are. So there's 30 things. And so if you do that calculation in your calculator, you get 1.56 repeated forever, which is exactly what we get from the Excel spreadsheet. And so just to kind of show you that step by step, if we do the sum, that's equals sum. I'm just showing you how this works. You don't have to do it this way, but the sum is 47, and then if we do the sum divided by the number of things, then that's going to be, we can just click this to grab that number, divided by, there was 30 things, and so you can see how those match. The mean is just the sum divided by the number of things. Now, if you want to be an Excel pro, we wouldn't put in the number 30. We would put in the function count, and then it would count the number of things for us, so that if we add things to this column, then it'll automatically update that count. So, for example, like if I inserted another 1 here, you can see that it automatically updates everything. That's just kind of a power trick for Excel, that if you add or remove things, it can kind of keep your functions up to date, because if you didn't use the count, you'd have to manually update it to 30 elements. So that's how you can calculate the mean with a frequency distribution. So I've used Excel. The book does have a video on how to do most of that stuff in Google Sheets, and it even references the fact that there's mode mult and mode singular and all of that stuff. So, and I would advise you work on this example. I'm not gonna do it for this video because we're running up on 30 minutes now. But you can, after watching that video, go through this example about how to do that stuff in either Excel or in Google Sheets, whichever one you prefer, using that in-state tuition document that they've gotten there to find the mean, median, and mode of those in-state tuition values. So that's all I have for this video. Now that you've watched it, I hope you took some notes, you've paid attention. Now that you've done that, go back, read the videos, try the U-tries, the ones that I haven't done. Look at those examples that I told you to look for, and then when you've done all that, you've watched, now it's time to practice. Head on over to the LMS and work on your online homework.